how are you? Thanks for checking back in on math today. Let's keep rolling with Unit 7. First of all, we're going to skip around a little bit. As we learn how to factor polynomials, remember I taught you there's many ways to do this, right? There's these different questions you can be asking yourself, and like we've learned difference of squares. We've learned about factoring the long way. We've learned about can you factor anything out. And so these don't have to be taught in any specific order. So today we're going to kind of jump ahead in Unit 7, jump to Lesson 10. We're going to come back and do Lesson 9 later in the week. But for now, I want to show you how to factor polynomials using something that's called grouping. Grouping is what you have to do. Yes, I said have to do when you have 4 terms. So if you have 4 terms, you had better be grouping. Okay? As always, I think that having this little hint sheet or these 5 questions handy is super important. I'm going to encourage you again to write this into your notes if you haven't done so, or type it into a document and just save it somewhere so you have it handy. If you have access to a printer, print it out. It just walks you through any polynomial that you're going to be factoring. And if you kind of work your way through these questions, eventually you're going to find the right technique to use to factor that polynomial. All right? So, question number 1 is, can I factor anything out? We're still going to be asking ourselves that today, although I'm pretty sure the answer for our problems today is no. We're not going to be able to factor anything out. This is the new part. Question number 2, do I have 4 terms? If you do, and today you will, we're going to factor by grouping. Now from there, you might have a difference of squares and other things, but this is really, number 2 is the important part. Here are their steps, and sometimes I like what they provide for steps, and other times I don't care for it, but these steps are okay. So this is a polynomial. It has 4 terms, and because it has 4 terms, we have to factor by grouping. Step 1, group the first 2 terms together and the last 2 terms together. That means you put parentheses around these guys and parentheses around those guys. You group them. Step 2, factor out the greatest common factor. That's the can I factor anything out? Oops. Can I factor anything out? So you look at the first one, x to the third plus 7x squared. What can they both give? They can both give an x squared. So you take an x squared out of this set of parentheses. What would it leave behind? An x here and a plus 7 there. Right? So I just worked on that first set of parentheses. Now we do the same for the second set of parentheses, and I'm going to give you a hint. When you do this for the second set of parentheses, whatever you factor out and you pull out here and whatever gets left behind, this set of parentheses should match that. So we should end up with an x plus 7. So if you can train yourself now to plan ahead and think for how we could leave behind an x plus 7 here, that's going to serve you well moving forward. Specifically, this is going to happen when do we take out a neg? You'll see what I mean. But ultimately, whatever we factor out of the second set of parentheses, the remaining terms or the remaining expression here needs to match that. Okay, so watch. Here we go. What can come out of a 2x and a 14? A 2 can come out. So we take a 2 out, leaves behind an x plus 7. And see how they match? That's what you want. Now, this is where their wording is confusing. It's not hard, it's just weird to put it in words. The greatest common factor from each binomial will become one factor, and remaining binomial will be the other factor. So what they're saying is what you pulled out of this one and what you pulled out of this one becomes one factor in parentheses. So that's like the outside stuff. And then the other factor is this one that you have that's in common. So an x plus 7 and an x plus 7, although you only write it once. Now, if you want to be sure your answer is right, you can FOIL it, which we'll do for this example, but we're not going to FOIL all of these. First, outer, inner, last. So first would be x to the third. Outer would be 7x squared. Inner would be 2x squared. And last would be 14. Does that match the original? It sure does. It sure does. And I know you're probably thinking, Glessner, we could put those together and call that plus 9x squared. That's true, but then you wouldn't have 4 terms. So they're saying you can use FOIL just to check and make sure you end up with the same 4 terms that you started with. Okay, we're going to do some more for practice. And I think we're going to do it on lined paper because, you know, I just hate how tiny they use or make their print. Remember, when I number my examples, it's really more for my benefit than yours. Let's do number 1 on my sheet. 3x to the third plus 15 x squared minus 2x minus 10. Can I factor anything out? The answer is no. Do I have 4 terms? Yes, I do. 4 terms means grouping, right? Look. No, yes. Factor by grouping. These guys go together, and these guys go together. Okay, what can come out here? You could divide out a 3 and an x2. That would leave behind an x and a plus 5. Okay? Now, remember, whatever I take out of here, we want this set of parentheses to match this. So we want it to say x plus 5. What can you take out of this to leave behind a positive 1x and a positive 5? You'd have to take out a negative 2. See, and that's where understanding that these two need to match is important. Yes, there is a 1 there. They do match. Because originally when you look at this set of parentheses and you're asking yourself, what can I factor out? Well, you could factor out a negative 2, or technically you could have factored out a positive 2. So which do you take out? Do you take out the negative 2 or the positive 2? Well, you need to take out whatever leaves a matching set or a matching factor. So in this case, it was take out the negative 2. Okay, so this becomes one set of parentheses, and this is the other set of parentheses. So there's 1, and x plus 5 is the other. So even though this one's here twice, you only represent it once. And if you FOIL this, lo and behold, you would end up with our original expression. Okay, let's do another. Can I factor anything out? Can they all give up something? Nope. Do you have 4 terms? Sure do. So, grouping. Group, group. What can come out of here? They can each give a 4 and an x. So take out a 4x. What gets left behind? A 2x here and a plus 3 there. So guess what? Set yourself up for success. You want to have a matching expression in parentheses here. So what could I take out of this to leave this behind? A y can come out, right? This guy can give a y and he can give a y. And that's what comes out, a positive y. Right? Okay, final answer. You have a 4x plus y and a 2x plus 3. You're done. You just factored that quadratic, or I shouldn't call it a quadratic. You factored that polynomial. Cool. Let's do a couple more. We don't really need to do a whole bunch more, but we'll do a few more. This is technically number 8, although, again, you don't really care about that. 2x squared y plus 6xy minus x minus 3. Can I factor anything out? No. Do I have 4 terms? Yes. Grouping. What? He can give a 2 and a 2 and an x and an x and a y and a y. So a 2xy comes out, leaving behind a 1x and a 3. That's it. So now, remember, this, you need this to match this one. So we want to leave behind a positive 1x and a positive 3. So now, what can you take out of here such that it matches, right? You'd have to take out a negative 1, right? Because that would turn that to a positive, and the taking a negative 1 out of here would turn to a positive. It's like dividing out. All right, here we go. Final factors are 2xy minus 1. Remember, that's the outside stuff. And then the inside one, which should be matching. There you go. Okay? Do you think, what, 1 more? 2 more? I don't know. I never know. Especially when you're not in the same room as me. Oh, look at those fingernails. Oh, would you look? Who? What? What is this? Whose nails are those? It's terrible. Look at this one. What? Oh my gosh. So embarrassed. Oh no. Just doing my best over here, kids. Just doing my best. Okay? Let's do number 10. If we were in the classroom right now, I'd probably say, what do you think? 1 more? 2 more? 4 more? And you would answer, and then we would proceed forward. But I can't have that discussion with you, so I never really know how many examples to do. Let's do 2 more. Okay. Look at that. Okay. Nothing can factor out. You have 4 terms. It's grouping. Okay. A squared comes out, leaves behind an A and a B. Guess what? You know what we want, right? You know that, because we want it to match. So what would I have to factor out of this to get to here? Well, you have to take a B out. A positive B comes out. So you take your outside stuff, put it in parentheses, and then your matching insides, and you represent that once. Boom! Factor by grouping. 1 more. These aren't too bad, do you think? I don't think they're too bad once you get the hang of it. Okay, last one. Number 12 says x squared y squared minus 3x squared plus 2 y squared minus 6. Can't factor anything out, but it's 4 terms. 4 terms is groups. Group these fellas and these fellas. You see with all that, he can give x squared and he can give x squared. That comes out. Leaving behind y squared and a minus 3, which is what we want to have left over here. That means I'd have to take out a positive 2. Outside stuff. Inside stuff. Done. Factored. Cool. So, time for a pep talk. Good job to those of you who have been really killing it. I see every day who is checking in, who's watching the videos, who's doing the IXLs, who's doing the assignments. I check what you guys turn in every single day, and I actually keep a spreadsheet, a little checklist. Maybe I'll show you. But anyways, I keep this little checklist, and I can, here, I'll show you. Here, hold on just a second. Okay. Obviously, I can't show names because I don't want to, give it away. But this is what I'm talking about. I do this every single day. I update this with different colors of check marks and whatnot. So you can see every day, period 6. This started on, can you see, May 4th, and then the 5th and the 7th. So I do all the assignments and I do the dates, and I do check marks every day for who turned stuff in. Now, if a check mark's a different color, that means the kid probably handed it in late, or I just picked up a different color marker. So at a glance, I can see for period 6 who's engaging on what level. So this student engaged 5 times out of these 7. Here's somebody who did all 7. Here's somebody who did all 7, all 7, all 7. This kid did 6 out of 7. Here we're at 5 out of 7. So I just want you to know, and I do this for all my classes. I do it for every single class I have. I keep these checklists of work completion. Some classes are obviously better than others, but I want you to know I see it. Okay, I look at these spreadsheets all day long. I see if you're visiting with math every day. I do, and I appreciate it. And I know some of you will check out for like 5 days at a time, and then you sit and work for hours, like you start turning stuff in, like I'll get 5 assignments from you sometimes in the middle of the night. And I understand that may just be how you want to do it, and that's okay. I wouldn't say that that's the best way to do it, but you can do this however you'd like, so long as you get the work done. So those of you that are working either on a daily basis or maybe you sit and work all at once, I just want you to know I appreciate it, and I see it, and I pay attention to it every single day, okay? So I hope you're doing well. I hope your family is doing well. I feel like our weather has finally started to take a turn for the better. Thank goodness. The sun is currently shining, and the birds are singing as I'm making this recording. So it doesn't get a whole lot better than that. So take care. Be in touch as needed. And I will see you on the flip side.